Hello students, so welcome again. Here I am with another problem on conic section. This time I am going to solve a problem of construction of an ellipse by rectangle method. Again in the problem, the major axis and the minor axis of the ellipse will be given to me. That is one of the simplest problem. Given that major axis AB will be 120 mm and minor axis CD will be 80 mm. As you know that major and minor are perpendicular bisector. So what we have done, initially we started with AB, a horizontal line, that is 120 mm, and perpendicular bisector of that CD will be 80 mm. As you know that the major axis and the minor axis will terminate at the curve. So A, B, C and D are the 4 points on the ellipse. Now this time I am going to use a method that is known as rectangle method. As the name suggests, I am going to bound these two lines inside a rectangle, and that will be a rectangle of size AB and CD. So for that, what I am going to do, I will draw parallel lines from C and D parallel to AB, and from A and B I will draw lines parallel to CD. So that is the simplest way. You can use the roller scale or mini drafter. I am using this method of arc to draw parallel lines. So what I have done, I am going to draw a line from A that is parallel to CD, and also from B the line parallel to CD, and from C I will draw a line parallel to AB like this, and from D also I will draw a line parallel to AB. So now simple construction will be there. What I have done, after drawing AB and CD, I have drawn lines parallel to AB from C and D, that is the end of the minor axis, and from the end of the major axis I have drawn a line parallel to minor axis. So the whole figure will be, you are getting a big rectangle of size 120 mm into 80 mm. If I name this, then that may be E, F, G and H. And if this will be the center of the ellipse, so that will be the point O. So if you look at this figure, here we are having 4 rectangles, equal rectangles, and as you know that ellipse will be symmetrical both side of the major axis and both side of the minor axis. So piece by piece I am going to draw the 1/4 part of the ellipse here, then second, then third and then fourth. So initially I want to work only on the first rectangle, that is A, O, C and E. In this A, O, C and E, this AO will be the bigger side, CE will be the shorter side. What I am going to do, I am going to divide this AO and AE. I am going to divide these two lines into same number of equal parts. How many parts, that we have to decide. So what we have to do, we have to divide this AO and AE into same number of equal parts. So right now, suppose if I have decided that I am going to divide this AO and AE in 4 equal parts. So I am going to divide these into 4 parts. So this total length will be 60 mm. So 1/4 of the 60 will be 15 mm. So 15 mm if I mark, then I can easily divide this into 4 parts. Here I am using the approximation method. So I have divided this AO into 4 parts. Same way this AE, that is equals to 40 mm. If I want to divide that into 4 parts, then one part will be 10 mm. So what I will do, I will divide this into 4 equal parts. Again I am using this approximation method. So what I have done, I have divided this AO and AE into same number of equal parts. Now I will name A towards O. If I will name this 1, 2 and 3, A towards O, then same again A towards C, I will name this 1 dash, 2 dash and 3 dash. After doing this, what we are going to do, I am going to match this C point with A dash, 1 dash, like this. After joining the end of the minor axis, that is C, with 1 dash, the other end D I am going to join with point 1 and extend this line towards the upper line. The intersection of these 2 points, these 2 lines, this point will be one of the point on the elliptical curve. This is a very simple method. Again, just check, again I am using one more time. This time what I am going to do, I am going to join this C with 2 dash like this and join this D with 2 and extend this line upside. Again the intersection of these 2 will be the point on the curve. Same way, third point, from this I will join this 3 dash with C and again this D will be joined with 3 and I can extend this upside. Again the intersection will be the point on the curve. So now look at this figure. We have A will be one of the point on the curve, then this 1 point, 2 point, 3 point and finally C. So for this patch I have 5 points. If I join all these 5 points by the smooth curve like this, I can easily get the 1/4 part of the ellipse. So this is the method. Now same method I am going to repeat in the right side also and in the lower side also. So little again what I am going to do, I will divide this line into OB into 4 parts. And same way I can divide this upper line into 4 parts. Again this time the naming will be B towards O. So this will be 1, this will be 2 and this will be 3. Same way B towards F. So this will be 1 dash, 2 dash and 3 dash. And again I am going to repeat the same method. I am going to join this C with 1 dash and this D with 1 like this and extend this upside. I can easily get the point. Same way C with 2 dash and this D with 2 and extend this line upside. So that is another point on the curve. Then this 3 dash, so this D with 3. Again I can easily get these points. Another point, another, then again in the same manner I can join these points by a smooth curve. And I can easily get the 2/4 part of the ellipse. Same method we can apply downside, or as you know that the figure will be symmetrical on the both the sides. So one shortcut method will be like this. If I move from this point perpendicular downside, then this upper distance and the lower distance for the lower point will be same. Same way I can move parallel on this point and come perpendicular downside. Same way come perpendicular from this point here also. So what I am going to do, I am shifting perpendicular downside and marking the lower side point. So this upper distance of the point will be on the lower side also at the same distance. Same way this point that come downside, this third point, same way here. This is one point, second point, and so twice I have used that method. Then just shifting perpendicular, even we can go in that side also, as you know that the curve will be similar in both sides of the major axis also, minor axis also. So I can get easily got these points. Now join these points with the curve. Similarly in this lower side, left side also. So this is the required curve, that is ellipse by rectangle method. Now suppose again if there will be a question that we have to draw tangent and normal on this curve, then as you know that for getting the drawing the tangent and normal, we have initially we have to find out the focus of the ellipse, and as you know that the distance of the focus from the end of the minor axis will be equals to half AB, or you can say that this equation earlier we have used that CF1 equals to CF2 equals to half AB. So what I am going to do, I will pick the length half of the AB, and from this C as center, if I cut this major axis from C and D both sides, then I can easily get this point. Same way in the opposite side also. You can easily get the second focus, that is F1 and F2. Now if we want to draw a tangent and normal, suppose this time I am saying I want to draw a tangent and a normal on a point which is 20 mm from the major axis. So 20 mm from the major axis, initially what I will do, I will mark a point at 20 mm from the major axis on this line. This is 40 mm, so midpoint of that. And if I move parallel from this point on the curve, then this is the required point, suppose the point P, which is 20 mm from major axis. Now if I want to draw a tangent and normal on this point, then what I have to do, I have to join this point P with focus F1 and F2. So this is F1. So what I have done, after marking the point P, I have joined this point P with focus F1 and F2, and after that I will bisect this angle. So for bisecting this angle, what I will do, I will draw two arcs in compass, take any length and draw this arc. Then after that again taking these two centers, make another arc. Then you can easily bisect this angle, and the angle bisector of this will be the normal, and perpendicular to this angle bisector, that will be tangent on the curve. So in this way you can easily draw tangent and normal on any point on the curve, but for that you have to initially find out the focus f1 and f2. This is also one of the easiest method. I hope you understand the concept. Draw it in your sketchbook. Thank you very much.